let's just work on hash maps. Ah, this is so gay. That's the thing with like UK gangsters, right? They look so tough, but the issue is they look so pussies with these on, you know? It's like, bro, you talking about fucking stabbing a guy with these on, you know what I mean? Because your fingers are too cold. Come on, bro, that ain't tough. That ain't tough, broski. That ain't tough. Can I copy the code somewhere? So if, what is the code? So if I, what is this thing? It's gonna be 1. If 1 is, okay. If these two are true, do that, or else do this. And return the thing, okay? Whatever these conditions are, I'm just gonna subtract. Why am I subtracting result? Roman, fuck you. Okay, this one I understand. I'm moving on to the next. Okay, it's iterative. Okay. So, if I plus 1, something like that, is bigger than length of S, and it should be bigger I don't understand that part. What is this? Roman S is bigger than Roman. Okay, this, if that is true, and also this number is bigger than this number, so that will be Rome of, okay, S, so the first letter of that, if it's bigger than this one, okay. No, what should I return? I should return that is true. I need to return, no, I don't think I should return. I should get the result. Result should be 0. I need to minus the result from the Rome, that thing. I don't really understand the code, if I'm being honest, but it is what it is. Else I need to add the thing. So This should work technically, but I don't really understand the explain. That's my chat GPT. Okay, these are the dictionary of the Roman values. This maps each Roman symbol to the integer value. Result starts at 0. It should start with 0, obviously. Loop through each character. That makes sense. We check each character in the Roman string by index. So we're using the index to go over the entire string. So it should be the first. What would be the first string? So if it is 23, let's say 24, it'll factor in 2. No. If it is 24, what would it do? Let's say, yeah. Index is I character, next character rule. Okay, that makes sense. We have it's the first iteration when I is equal to 0. C next value is bigger, right? It's in the 100th place and the next value is bigger. S of I is bigger, so I'm minusing it. $898. Shouldn't this be minused? Why is it a special rule for 9? Because logically you could just go DCC for 4 times, right? Why can't you? I don't understand this code at all. I'm gonna move on to the next one. Linked list cycle? No way. Wait, why should I understand linked list to do this shit? Can't I just... I understand it, but fuck. Happy numbers. So let's do this. write an algorithm to determine a number if happy and number n is happy. A happy number is a number defined by the following process: starting with any positive integer, replace the number by sum of square of its digit, repeat the process until the number equals 1, where it says a loop of endless cycle which does not include 1. Worst number. Okay, let's go. A little bit of a 2-pointer, but we don't care. What am I doing again? Let's go to this thing. Explain the problem.
Hey everyone, welcome back, and let's write some more neat code today. So today we're going to look at LeetCode 202, happy number. So what makes a number happy? They explain it to us in the problem statement. So we're given an input number n, and we want to know, is it happy or not? If it's happy, we can return true and we're done. If it's not happy, we're going to return false. But how do you determine if it's a happy number or not? In this example, they gave us a 19. So let's work with that. So all we need to do is take each digit. So the first digit, 1, square it. The second digit, 9, square it. Add them together and then compute the sum. But we're not done yet. To determine if it's actually happy or not, we're going to take this number now and do the same thing. And we're going to keep repeating this process, right? So we would take 8 squared plus 2 squared, and then we get 68. And we're going to keep going. Now, if the number reaches a 1, just like it did in this example, so eventually we're going to go to 68, we're going to go to 100, and then we're going to get to 1. And if it reaches a 1 like this, then it's a happy number. If it doesn't ever reach a 1, then it's not a happy number, and we're going to return false. But they also tell us that no matter what, whether it's a happy number or not, it's going to loop endlessly. So notice how this 1, if you take 1 and square it, 1 squared is equal to 1. 1 squared is equal to 1. So when we keep doing this, we're going to get stuck in an infinite loop. But even if we never reach a 1, we'll still be stuck in an infinite loop. So you guys know how much I like to visualize problems, so let's do exactly that. So we start with a 19.
Sometimes, let's say that's like a 3. You know how when you divide a number and there's like a 0.33333 shit happening. So I think that kind of like, that would be like an edge case. You know, that kind of an idea could be.
Then we get to 82.
Let's go.
Then we get to 68. Then we get to 100.
It's 2-pointer.
And then we get to the number that proves to us that 19 is happy. Now we get to a 1, right? And now this 1 is going to loop infinitely. And therefore we know that 19 is a happy number. But let's take a look at a different example. What if our input was equal to 2 instead of 19? Then what's going to happen? So, and we get to 16, we're going to get to 37. If we take the sum of squares of 37, which is 9 and 21, we get to 30. Next, 3 squared plus 0 squared, that's a 9. 9 squared is 81. 81 squared is 65. 65 squared is 61, or the sum of squares of 65 is 61. And now 6 squared plus 1 squared is 37. And you notice anything about this? There's a 37 right over here. So basically the exact same thing happened, right? We started at 2, we did some stuff, and then we got stuck in an infinite loop, right? It's just going to keep going around and around and around infinitely, right? So what does this tell us? Well, in this case, the input number 2 is not happy. So instead of returning true, we're going to return false. So basically what we're trying to do is check if we
This shit is like Sisyphus.
ever get to, basically, do we ever visit a number twice? And how can we do that efficiently? Well, you might have heard there's a data structure called a hash set that we can use, and I'm going to show you how to code that up right now. So I'm doing this in Python, so let's create a visit hash set to keep track.
So what is the difference between a hash map and a hash set? So let's just look into this video.
Track of every number that we previously visited, so that if we get to a number that we visit twice, we can instantly know in constant speed, right? Hash sets are really quick. And now we just want to compute the sum of squares of n until n is repeated, until we get a duplicate value. So I'm going to go until n is not in visit. So if n hasn't been visited, then the first thing we can do is add it to our visit hash set. And the next thing we want to do is compute the sum of squares. So I'm not going to do that here. I'm going to separate that out into a helper function like I'm doing right now. So we're going to pass n into this function. We're going to compute the sum of squares, and we're going to reassign n to that value. So before I forget, let me actually define this helper function. And so what's going to be the condition that we return true? So remember, the single number that we're looking for is 1. If n
This is not the correct solution.
ever equals 1, we're done. Like, we can just return true. And we could have even put this part like at the beginning of our code if we wanted to. If the input value was 1, just instantly return 1. We don't even need to do anything. But in the case that we visit a value twice, like if our loop stops executing, that means we visited a value twice. But in the case that we visited a value twice and that value was not 1, then we need to return false because we know our loop is going to stop.
Have you ever wondered why 19 is
Bro, why does he look... Am I gonna end up like this?
considered a happy number? Take its individual digits and you square those together and then sum the result, you are going to be left with a different number. Well, watch what happens when we keep doing this. We get 8 squared, which is going to be 64, plus 2 squared, which is 4. That gives us a new sum of 68. If we do this 2 more times, 68 is going to give us 36 plus 64, and together that gives... Safe. Have you ever wondered why 19 is considered a happy number? Take its individual digits and you square those together and then sum the result, you are going to be left with a different number. Well, watch what happens when we keep doing this. We get 8 squared, which is going to be 64, plus 2 squared, which is 4. That gives us a new sum of 68. If we do this 2 more times, 68 is going to give us 36 plus 64, and together that gives us the sum of 100. You do this 1 more time, you just end up with 1 squared, ultimately ending in 1. And that is why 19 is a happy number. An unhappy number like 2, you could keep this process going forever. 2 squared is 4, 4 squared is 16, then you would have 37. This process would never end. So to keep track of the cycles, you can use a hash set and see what you've seen before. To use constant space, you would use a slow and fast pointer technique and check if slow is ever equal to fast. Learn all of this stuff completely for free at algomap.io. Have you ever wondered why 9
Nigga, just give me the fucking solution, bro. Is it a linkless solution? Why?
Write a 202 happy number. Write an algorithm to determine if a number is happy. A happy number is a number defined by the following process. Starting with any positive integer, replace the number by the sum of the squares of its digits, and repeat the process until the number equals 1, where it will stay. Or it loops endlessly in a cycle which does not include 1. Those numbers for which this process ends in 1 are happy numbers. Okay. So we look at any positive integer, the sum of the square of its digits. Okay.
Bro, I have better quality than this. What the fuck?
Okay. Where is that? You can thing and 0,000 of how it works. So we could actually just we keep track of all the numbers that we've been to under 1,000. Then it should be okay. And then if we get to 1, that's great too. So yeah. Okay, let me just do it this way. Next.
Do it in Python,
Oh man,
bro.
why is this in bold, you ask? And the answer is you right.
Fast and slow pointers, a powerful pattern where you use 2 pointers and move them at different speeds. It can help you solve multiple linked list and array related problems like finding cycles in a linked list, finding middle node of a linked list, or detecting cyclic properties in arrays. The beauty of this pattern lies in how efficiently it solves these types of problems. It only uses O of n time and O of only space complexity. Plus, you can solve these types of problems in just one pass through the data. In this video, you will learn what the fast and slow pointer is, when to use it, and I will walk you through multiple lead code problems to help you understand it better. I will also share some more lead code problems you can practice afterwards to master this pattern. Alright, so what exactly is the fast and slow pointers pattern? Let's use a real world example. Imagine 2 runners A and B on a circular track. Runner
So wait.
A is running faster than runner B. Since the track is circular, at some point, runner A will catch up to and pass runner B. This is essentially how the fast and slow pointer pattern works. It uses 2 pointers. One pointer moves slowly while the other moves faster. If there is a cycle in the data structure, both pointers will eventually enter the cycle. Then the fast pointer will catch up to and pass the slower one. Now let's go through some actual leet code problems to see this pattern in action. Just a quick note, if at any point you feel like pausing the video and trying out the problem yourself, I encourage you to do that. The first problem is leet code 141 linked list cycle. You are given a linked list and you need to check if it contains a cycle. A cycle in a linked list occurs when a node's next pointer points back to a previous node. One straightforward approach to solve this problem is by using a hash set to track the nodes you have already visited. Here is how it works. Start at the head of the linked list. For each node, check if it's already
This is hash set,
in the hash set. If it is, you have found a cycle as you are revisiting one of the previous nodes. If not, add the current node to the hash set. If you reach the end of the list without revisiting any nodes, then there is no cycle. This method is simple to implement, but there is a catch. It uses extra memory to keep track of the nodes you have already seen. If there is no cycle in the linked list, it will end up storing all the nodes in the hash. This leads to a space complexity of order of n, where n is the number of nodes. We can do better by avoiding the extra memory, and this is where the fast and slow pointer technique comes in. Here's the idea. Initialize 2 pointers, slow and fast, both starting at the head of the linked list. Move the slow pointer 1 step at a time and the fast pointer 2 steps at a time. There are 2 possible outcomes. The slow and fast pointers meet. If this happens, there is a cycle in the linked list, or the fast pointer reaches the end of the list. In this case, there is no cycle. But why does this work? Let's break it down. The fast pointer enters the cycle first. Once the slow pointer enters the cycle, the fast pointer is already inside the cycle. The fast pointer gets closer to the slow pointer by 1 step each time they both move within the cycle. Eventually, the fast pointer will be right behind the slow pointer, and on the next move, they will meet. Before we move on to the next problem, I wanted to let you know that I will be creating more such videos on leet code patterns. So be sure to subscribe so that you don't miss my new videos. Let's move on to the second problem. Leet code 876, middle of the linked list. You are given a linked list and you need to return the middle node. If the list has an odd number of nodes, return the middle one. But if the list has an even number of nodes, you need to return the second of the 2 middle nodes. One simple way to solve this problem is by counting the number of nodes in the linked list, then starting at the beginning and moving forward by half the total number of nodes. This approach works and it's efficient in terms of time and space complexity. But the drawback is that you need to traverse the linked list twice, first to count the nodes and second to actually find the middle node. We can make this solution more efficient by using the fast and slow pointers technique, which will allow us to find the middle node in just one pass. Here is how it works. We start with 2 pointers, slow and fast, both at the head of the linked list. Move the slow pointer 1 step at a time and the fast pointer 2 steps at a time. When the fast pointer reaches the end of the linked list, the slow pointer will be at the middle node. This method works whether the list has an odd or even number of nodes. Here I'm using Java, but you can find code for other popular programming languages in my GitHub repository called Awesome Leet Code Resources. You can find the link in the description. Problem 3, leet code 202, happy number. The problem asks you to determine if a number is a happy number. Here is what makes a number happy. You start with a positive integer, replace that number with the sum of the squares of its digits. Keep repeating this process until either you end up with 1, which means the number is happy, or you get stuck in a loop, meaning the number will never reach 1, and it's not happy. One straightforward approach to solve this problem is by using a hash set to keep track of the numbers we have seen. Here is the idea. As you calculate new numbers, add them to the hash set. If you ever encounter a number that's already in the hash set, that means we are in a loop and the number is not happy. If you reach 1, the number is happy. This approach works, but it uses extra memory to store all the numbers we have seen, which can become inefficient for very large numbers. We can make this more efficient by using the fast and slow pointers technique, similar to detecting cycles in a linked list. Here is how it works. Imagine the starting number as the head of the linked list. Treat each number you get after summing the squares of its digits as a node in a linked list. If we keep getting new numbers without repeating, it's like moving straight through a linked list. If you ever reach a number you have seen before, you have found a cycle. To detect the cycle, we use 2 pointers, a slow pointer that moves 1 step at a time and a fast pointer that moves 2 steps at a time. If both pointers eventually meet, you have detected a cycle, meaning the number is not happy. But if the fast pointer reaches 1, the number is happy. Here is how the approach looks like in code. First, define a helper function, getNext, that calculates the sum of squares of digits. Start with 2 pointers, slow at the original number and fast at getNext of n. Inside a loop, move the slow pointer 1 step at a time, which means sum of squares of digits once, and move the fast pointer 2 steps at a time, which means sum of squares of digits twice.
Graphs, one of the most powerful data structures in computer science. They are made up of nodes and edges. And from this simple idea, we can model incredibly complex real-world systems. Graphs are also an important topic for coding interviews. On leet code, there are over 170 problems tagged as graph. And even more if you count problems related to graph algorithms like depth first search and breadth first search. In this video, I will cover what a graph is and how it works,
graphs and trees and arrays are like
the different types of graphs, different ways to represent graphs in code, and the most important graph algorithms you should know for interviews. Let's get started. So what is a graph? A graph is a data structure to represent relationships between different entities. A graph is made up of 2 things. First, weighted. Graphs can be classified in multiple ways, really mean NS from B. Second, weighted versus unweighted graph. In a weighted graph, each edge carries a cost. Now that we understand this, an adjacency matrix uses a...
I truly do believe that premature optimization is the root of all evil.
Graphs, one of the most powerful data structures in computer science. They are made up of nodes and edges. And from this
question happy number. It's an easy legal question. Write an algorithm to determine if n is a happy number. Basically, if it's a happy number, that means that, look at it, this example is that a, and you do 68 and add up to 100, and you're going to continue to go through this loop in the circle until the last 4, right? 4 will be 16, and 16 is if a number is every single number, that's n equals to 1, then you can solve this problem first, and I'm going to pass into the n as the get n function. I will calculate every single number and adds the sum together. Basically, I'm going to set n sum at the beginning equals to 9 in this case, and since I do diff mode on 19, and then that's the result that I will be getting. And then the next step is I'm going to add up the n sum. So n sum is basically you add up and n set. So essentially I'm going to add 82, 68, 100.
First of all, there is no such thing as a happy number. It is just a problem statement and you have to solve for it. Let's face it. Let's face it, most likely you will be only opening leetcode.com when you have a tech interview coming up, right? And in fact, LeetCode is the gold standard when it comes to preparing for coding interviews because it has so many problems and so many variations of all the questions that are being asked by these tech companies, correct? And given the fact that you have so little time and so many distractions around you, even selecting which problem to solve, this can become a basic hurdle. So you must understand. Let's face it, most likely you will be how many are medium and how many are hard. And along with that, it will also give you a
This is the goal.
collection of all the problems that you have submitted. It will tell you how many were sure that you are not just solving a lot of time. And trust me, not every question on LeetCode has a high quality. Some of them are poorly written, some of them have bad test cases, and you will just end up wasting a lot of time if you try to solve each and every one of them. Okay, so what do you do now? If you look to the right, you have a section called featured list, and you might be wondering that, okay, top interview questions. This looks like a good place to start. And indeed, this certainly is a curated list and it only has 145 problems. So one approach is that, okay, you can try to sort all of these problems by difficulty. You can start solving the easy ones first and then go on to medium and then hard. This sounds like a plan, right? And it will work best in most of the cases. But even in this, you have to sometimes determine what is the quality of the question. There are additional metrics that can help you decide that is a question even worth solving or not. For example, just look at this question reverse integer. So don't just start solving this question straight away. Just look at the number of likes this question has and the number of dislikes. This question is liked by 9,000 people and it is disliked by 11,000 people. So try to understand. LeetCode is a community-driven platform. And whenever I see that a question has more dislikes than the number of likes, I personally skip that question. And it comes from experience as well. I have often seen that in such scenarios, either the question is poorly written, or it has some ambiguous test cases, or it will have some tricky test cases which were not clear from the problem statement itself. In other scenarios, these problems do not actually test your problem solving skills. For example, this question is asking you to reverse an integer. And there are so many libraries out there which can do it for you. So it is highly doubtful that your interviewer will ask you such a question because you have standard libraries exactly for this procedure. And just solving this will waste your time. So I would recommend you to stay away from them. You can see more questions like this. For example, reverse integer was 1, and then you have one more question, divide two integers. Once again, just look at it. 12,000 people have disliked this. Because this question is not testing any of your problem solving skills. It is just testing how well you are able to code or how well you are able to handle all the edge cases and how well you are staying within the limits. And trust me, this is not important from a coding point of view. Yes, when you are writing large scale applications, you might have to look for precision, but then it becomes a whole different story And this does not become relevant for your coding interviews. You will end up wasting so much of your time, which you could have used to learn another new concept. We can see one more problem. For example, power x to the power n. So once again, 7,000 people have disliked it. And what do you have to do? You have to implement the power function. Now think about it. Do you really need to waste your time trying to implement this function when there are libraries out there to do the exact same thing for you? And even in interviews, your interviewer will allow you that, okay, you can use the standard libraries available to you. The interviewer will be more interested in how you're approaching the problem and how you are getting to the solution using data structures, using different. Give you a current sentiment about.
Yeah. Let me start from the basics. Fuck. Okay, you're given an array of strings, return the longest common prefix. I'm gonna do that will be the n square test case, time complexity. So what I'm gonna do is I'm gonna check bro, that is enough. Should I do a binary I think I need to do a binary search. Yeah, it should be like, is this so I need to check if they're all the same. If string 1, fuck you. Okay, let's just longest common prefix. He purposefully doesn't like give the number for some reason.
Hey everyone, welcome back, and let's write some more neat code today. So today let's solve the problem longest common prefix. We're given a list of strings, and among all of these strings we want to return whatever is the longest common prefix. Now what is a prefix? Well, it's just a portion of the string. So for example, this string flight, a prefix is just any portion of the string starting from the beginning. So F is a prefix, FL is a prefix, FLI is a prefix, flight itself, the string itself, is a prefix. As long as it starts from the beginning and is continuous, then it's a prefix. And we want to return the longest common prefix among all of these strings. So, what's the intuitive way to tackle this problem? Well, look at the beginning, right? All three of these strings start with an F, right? So F is a common prefix among all of these strings. Let's look at the next character, L. L is, and we code it. If string, they both start with flow, right? So flow is a common prefix to both of these two strings. Then if we got to the fifth character, we'd see that, okay, E, and that makes sense to be the time character of every and we had it multiple times, right? Then we'd have to potentially iterate through each of those flower strings, right? Because they're common, so we wouldn't stop. And then we have to go through every single character. So the overall time complexity, let's say, is going to be n, where n is the total number of characters that were given. Or if you want to say that n is the average size of the string, and we have n. Let's say we didn't even have a common prefix among, right? So let's say could be possible that this string is not the shortest string in the input, right? In which case we'd want to stop this for loop earlier than it's actually shown right now. So we'll have to remember to handle that case. I'll handle it slightly differently than using a conditional out here. So we're iterating through every index. We want to now iterate through every single string and make sure all of the strings have the exact same character at index I. So let's go through every single string. So for S in the list of strings that we're given, we want to check that every single string at index I is the same. So let's compare this arbitrary string S to the first character of the first string, right? We could pick any of them, but we just want to make sure that they're all the same. So we'll just make sure to choose the same one every time. So we'll go to the first string, right? Strings at index 0 is the first string in the input, and then we'll go to index I of that string. So as long as they're equal, we're going to continue. If they're not equal though, which is this case, then we're going to have to return, right? We're going to have to return whatever our result is so far, because we know that whatever this prefix is, that's going to be the result, because we can't make the longest common prefix any longer. But there's one case that we didn't think about. What if we went out of bounds, right? What if this string S is out of bounds? Because we know this is going to be in bounds because that's our I pointer up above, right? I is always going to be in bounds of the first string because that's what we're iterating through up over here. But this string might go out of bounds. So before we check this condition, we're going to make sure that I is in bounds. So we're going to say that if I is equal to length of S, which means it's out of bounds, right? Then we're going to also return, right? We're not even going to check this line of code. If this evaluates to true, we'll immediately return. That's how Python works with the conditionals. If the first one is true, we don't even check the second one. And so that is the entire logic of the for loop. But remember, every time we go through a character, we want to add it to our result. So we can do that pretty easily like this. We can go ahead and add that character that is common among all the strings to our result. And then once we're done with all of that, we can go ahead and return the output result and we'll be good to go. So I'll run it to make sure that it works. And as you can see up above, yes, it works.
What the tree? We have the try, class try. Okay. What even is your thing, bro? Oh my god, bro. Oh my god. I don't want to use this shit, man. Alphanumerical fucking garbage. I want a heartbeat to the beat of the drum. Oh, what a shame. We got the dictionary for C and S. If C is close to open, this thing isn't okay. If C isn't that, if stack and the stack minus one, the first one, no, the last element. So yeah, I think that's how you access shit. So we can clearly see graphs is like really important. And yeah, array is like the most important thing. Fucking hell. I don't want to use this method, man. Respectfully though, don't want to use that shit. I don't want to use that shit.
Hey, what's up, guys? It's Nick White here. I do a tech and coding stuff on Twitch and YouTube. I'm in the library, so there's a lot of people talking around me right now, but we're going to try and do one of these videos really quickly. This problem is called valid palindrome, and you'd think it's pretty easy. I've done a lot of palindrome videos. I did like linked list palindrome and stuff. It is really easy. It's the same method as the other ones. You're using 2 pointers, which is a lot of palindrome problems. The only difference about this one is they do throw in this little trick here. Given a string, determine if it is a palindrome. And you guys know a palindrome just means a word that's spelled backwards the same way as it's spelled forward. So race car would be race car backwards. So that would be a palindrome, right? So the way we do this is we just have 2 pointers, one at the beginning and one at the end, and we move inwards letter by letter, one going backwards through the word, one going forward through the word, and we make sure the letters are the same. So, you know, we would have, we're going to have this.
So yeah, I think it's a 2-pointer, so I think I know what to do. You know what I'm gonna fuck. I don't even know, man. I don't even know.
This
What I know how to do it. I'm gonna call it okay, let me like devise a plan. I'm gonna do the blind 75 in order. I'm gonna come back. Why am I so why am I so not organized at all? So I need to do the blind 75 and nothing else. Blind 75. And we start posting on Twitter and OBS different streaming. I need to do that. And open source on free time. And I'm gonna do the projects. I'm gonna come back and do a project and see how it relates.